Welcome to this explainer. Today, we're diving straight into the absolutely incredible history of computers. We're going to trace their evolution all the way from simple wooden counting tools used centuries ago, right up to the wildly powerful artificial intelligence systems that we all use every single day.
So here's our roadmap for today. We'll be hitting 5 major evolutionary leaps: the dream to calculate, electronic brains and automation, the personal computer revolution, our connected digital world, and finally, artificial intelligence and tomorrow. Let's get right into it.
Part 1. The dream to calculate, a fundamental desire.
Long before we ever had electricity, humans still needed to count, right? For farming, trade, building, which drove this intense need for machines to help our minds process information. It all started in ancient times with the abacus, a simple bead frame, but honestly a massive leap forward for basic math. Then, fast forward to the 1600s, and Blaise Pascal creates the Pascaline. This was a mechanical gear calculator that proved, hey, machines can actually do mathematical work automatically. And all of this culminates in the 1800s with Charles Babbage's analytical engine, a totally revolutionary automatic calculator with a memory system that could follow instructions using punched cards.
But what's incredibly fascinating about this era is Ada Lovelace. While she was studying Babbage's design, she had this vision that was just light years ahead of her time. She famously realized that his machine could process abstract symbols, instructions, and ideas, not just raw mathematics. By writing an algorithm for it, she literally became the world's first computer programmer, laying the conceptual foundation for all modern software. How cool is that?
Moving on to Part 2, Electronic Brains and Automation. Data and automation. As society grew more complex, those mechanical gears just weren't cutting it anymore. They simply weren't fast enough. Governments and businesses had to process mountains of data, which brilliantly illustrates how massive societal problems drive technological innovation. Think about the 1880 U.S. Census. Processing it by hand was taking years. It was just way too slow. So to fix this, Herman Hollerith invents a machine that used physical holes punched into cards to represent information. This unlocked incredibly fast automated data processing. And guess what? Hollerith's highly successful invention eventually became the foundation for the tech giant we now know as IBM. Then, as we hit the 1940s, the Second World War created this immense, urgent pressure to calculate missile paths and break secret codes. This era birthed massive, literal room-sized machines. You had the Harvard Mark I using electromechanical relays. Over in Britain, you had Colossus, heavily influenced by Alan Turing's code-breaking concepts, using early electronic switches called vacuum tubes. And in the US, the ENIAC emerged as a general-purpose electronic computer. It filled an entire massive room and produced intense heat, but it could crush calculations in seconds that would have taken human beings days to do.
There was just one huge problem with early machines like the ENIAC. To program them, you had to physically plug in wires and flip switches. To solve this absolute nightmare, John von Neumann helped develop the stored program concept. This gave us a brilliant 4-step architecture: input, store in memory, process data, and output. Basically, the computer reads instructions from its own memory rather than needing someone to manually rewire the whole shebang. And the crazy part, this exact same logic flow is what your modern laptop and smartphones still use today.
Which brings us to Part 3, the personal computer revolution, power on your desk.
Now, the crucial point here is that up until this time, computers were strictly for governments, the military, and huge corporations. But an upcoming revolution was about to put that incredible processing power directly onto your own desk. To understand how computers shrank so drastically, we have to look at the hardware. Early machines used vacuum tubes, large, fragile glass tubes that got extremely hot and devoured massive amounts of electricity. Then, 1947 hits. Bell Labs invents the transistor, and it changes absolutely everything. Instead of giant, hot glass tubes, transistors act as tiny electrical switches that are highly reliable, run cool, and use very little electricity. A total game changer.
This intense miniaturization paved the way for the integrated circuit, or microchip, which eventually led to the microprocessor. Now, a microprocessor is essentially the central processing unit of a computer integrated onto a single, small microchip. So instead of needing a whole room full of parts to process data, the entire brain of the machine was placed onto one tiny chip. This is exactly what made personal single-user computers possible in the 1970s and 80s, brought to life by companies like Apple, IBM, and Microsoft.
But, making computers smaller just wasn't enough. They had to be easier to use.
Early personal computers relied on a command line interface. That meant you had to type exact, precise text commands and actually have serious technical knowledge to make anything happen. The ultimate fix for this was the Graphical User Interface, or GUI. With systems like the Apple Macintosh and Microsoft Windows, suddenly users could just visually click icons, open windows, and navigate menus using a mouse. It made computers friendly and totally accessible for students, writers, and everyday families.
So, personal computers completely transformed offices with tools like word processing and spreadsheets. People could finally edit text instantly and update financial data without doing manual recalculations. But the next logical question we really have to ask is, what happens when millions of these powerful, isolated machines actually connect and start talking to each other?
That brings us to part 4, the connected digital world, the Internet age.
This massive expansion really kicks off in the 1960s with ARPANET, linking university and military networks. Then, the 1990s gave us the World Wide Web, introducing browsers and links that made information accessible to absolutely anyone. Moving right into the 2000s, broadband and search engines categorized this endless sea of data. And today? Well, we have cloud computing, where our data and processing power just live on the internet, accessible from anywhere. This network completely transformed global business, entertainment, and even how people across the world learn languages.
And then, that immense connected computing power shrank even further, right into the palm of your hand. The smartphone completely revolutionized computing by absorbing countless physical items. Think about it. It replaced your camera, your music player, physical maps, your physical notebook, banking and payment devices, and even your gaming console. It essentially took all these completely separate tools and packed them all into one pocket-sized supercomputer.
And finally, part 5, artificial intelligence and tomorrow, future of computing.
We've arrived at the current frontier, where incredible processing power and massive amounts of big data have unlocked machines that don't just calculate anymore, they seem to actually learn. Artificial intelligence represents the latest evolutionary leap. AI can perform tasks that usually require human intelligence. It now understands human language, translates text instantly, analyzes complex medical data to help doctors diagnose patients, recommends videos, and actively assists users with grammar and language learning. It's wild.
And what's really fascinating is that computing is no longer confined to the screens on our desks or in our pockets. We've officially entered the era of embedded computing. This means small, dedicated computers are now hidden inside everyday objects. Tiny processors are constantly working away under the hood, inside everything from our cars to our washing machines and smart home devices.
Looking ahead, the future frontier is going to be wildly different from what we know today. Innovations like quantum computers have the potential to solve incredibly complex problems far, far faster than our current machines ever could. Meanwhile, virtual reality and augmented reality promise to create entirely new digital worlds and actually overlay data right onto our physical world. These technologies are going to radically reshape education, medicine, design, and even human communication.
To wrap up this explainer, I want to leave you with a really powerful final thought. A computer can help you learn, create, and grow. A phone can become your classroom, or it can become your biggest distraction. This incredible history, moving from the wooden beads of an abacus to brilliant artificial intelligence, has handed you the most powerful tool in human history. The technology is here, but the ultimate question is, what kind of future will you choose to build with it?